State chart types. Actually, we have different type of state chart. However, all this type is just to simplify the design and the understanding of the state charts. There is no actual difference between them. It's just to simplify the design and the understanding of the state charts. So we have two types: the flat state chart, which is the simplest form of the state charts. And in these state charts, all the states are represented in the state charts. There is no hiding state, there is no combining state, there is no composite state in these state charts. The second type is the hierarchical state charts. In this state chart, we have uh, we have something we call it is composite state or a super state, which is combining, which is a state has many or consist many states, many substates. So the first one is the flat state chart. This is the what we have seen in the previous example with the four ATM bin validations. So in this example, actually, we have all the states is represented. There is no hiding state, no combining state. So this is what we call it is the flat state chart. So the second one is the hierarchical state. So the state that this state is at least have uh, some composite state, which is combining other substates. So why this type of state chart? Actually, this type of state chart too, we can say to solve the problem of increasing the number of state. That once the number of state is increasing, it's the state chart is more complicated to understand and to design. So we can use this hierarchical state chart to simplify our design. We can combine some state. We can simplify the design by combining a substate each process. For example, the process of deposit it's become as a composite state. The process of withdrawal it's become as a composite state, and so on. So the idea here just uh, we can say it's simplify the design, simplify the state chart to become more understandable and easy to design also. So in the same example now we have this one is, as we see, is no hiding state, but here we combine some state together. For example, in this example, we combine the waiting for bin, validating the bin, and waiting for customer. So all of these state, we can consider that this is the process. Where is the process of the input of the user? So the user will insert the bin, and then we will go for one process, and this process is processing the customer input. So in this processing customer input, we can consider it as one state. These three state, we can consider it as one state, and these three state, it's together is composite state. So this one, the first type of hierarchicals, which is one state only. There is one composite state, and this composite state has many substates. So how we can represent now this composite state in the system? We just remove all, we just replace all these superstate by the composite state is like this. So as we say, just to simplify the use and the understanding of the state charts. So here we replace the composite state by another state. Also in composite state, it's also have two different types. So the first one is the sequential uh, composite state. Sequential, that means we have only one region of this state. So here the processing the customer input in the same flow. We have only one sequence. One sequence it goes one sequence in this composite state. One sequence is go from uh, waiting the bin, validating the bin, in okay cancel or go to the next step. So sometimes we can have more than one region. In the first one, if this composite is containing only one region, like this example, one region. So in this, we call it is non-orthogonal state charts. So the composite here only has one region. So in such situation, we call this one is non-orthogonal. So sometimes the process is dividing or partition into two region. So we call that is orthogonal, and this is used for concurrent system. So here the example of orthogonal state charts. As we say in this previous example, we have non-orthogonal, which is one region only, but orthogonal state charts have two region. So for example, here we have the first sequence for ATM sequence, and the second is, for example, requesting the condition. So we have two region. So such this state is called it's so if our state charts have one type or have any state or any composite state that have two region, so such state charts is called orthogonal state charts. So here the composition state chart is also two types based on the state composite state itself. So if the this superstate or composite state have one region, so we call this one is non-orthogonal state charts. If have two region, so we call this state is orthogonal state charts. Here another example of orthogonal state chart. This example is just for maintenance. So the maintenance is can go for testing or can go for second option, which is commanding. So such uh, this state chart is called orthogonal state charts. So in this example, uh, the maintenance state charts, which is composite state charts, it's have two regions. The first region is for testing as a part of maintenance, and the second region is commanding, which is give the instruction to the machine. Aggregation of state transition. So what we mean by aggregation of state transition? Actually, if you notice with me, in this example, after we combine these three states to composite state. So in this state, we have three states as a substate, and we have also here two states. It's out of these three states, or this is the destination of this composite state. So in this, if we compare these two figures, we have here the cancel any of these composition states. It's coming can cancel the operation anytime. So the transition from uh, the transition of cancel, it can come from any of these three states. However, so the confiscating state, it come only from validate the bill. So the composite states allow you to specify one state or one transition from this composite. As we say here, we have these three state. As we say here, the state of ejecting, it can come from any of these three states. However, the validation the bin in case the third attempt is failed or the card is stolen. So we go to the confiscating. The confiscating state is can come only from the validating the bin. So in this uh, in this case, the composite state is allow you to specify the one state or the source of the state as explaining here. So here, this is the composite state. However, we can see the ejection is coming from any of the three as it's in the first slide here. I mean, the ejection can come from any of these states. However, confiscating state is come only from validating the pen state. So this is what we mean by the aggregation of the state. So in case we have one state, it's come only from one state as a state inside the composition. So the composition states also, or the this type of composition state chart is can allow you to specify this state as a source. We come to the end. Actually is the same our example. This is the exercise. We have the elevators control system. We want to develop a state chart for describe for this elevators control system. The system is describing in lecture 4. So you just go and see there the description and try to develop the state charts. You can develop it as flat state charts. So this is the easy how to start developing the state charts. Just start with flat state charts and then later improve your design by developing the combining some state together, combining some process together, and come out with hierarchical state charts. We come to the end. Thank you for listening. See you next Monday.